Why are general relativity and quantum physics incompatible? How is it that macro world and micro world work according to different rules? Since we're also made of atoms, what does this say about us?
Yeah, this is one of the great problems of modern physics, is putting gravity and quantum mechanics together. So I don't think anyone would say it's impossible to put them together, but no one has succeeded yet. And part of it just is different length scales. That general relativity, the effects normally we would only see on very, very large scales of the distance of stars. Although, if you want to get extremely accurate, then you actually do need to pay attention to general relativity. The GPS satellite system that we all use actually uses general relativity in the calculations, and that's because they want to get extremely accurate to many decimal places. On the other hand, quantum mechanics, typically the effects are even much smaller scale than us, down at the atomic level. And so part of it is just the mismatch between those. Now, a lot of the normal physics that we experience is averaged over many, many particles. And so even in 1 gram of material, you might have 10 to the 23rd atoms, which is 1 with 23 zeros, and just an enormous number of atoms. And so almost always at the level that we live at, which we call the macroscopic, we're seeing average behavior of a lot of things. And so we don't see these tiny quantum mechanical effects. Now, that's not always true, actually. You can, I study things called Bose condensates. And you can have a Bose condensate or a superconductor which show quantum mechanical effects even in large-scale systems. So it's not quite accurate to say that quantum mechanics is always only at the small scale, but typically it is, and so we typically don't worry about it. But the other thing I would say is special relativity and general relativity are considered by most scientists to be very well understood, in some sense, classical theories, that they don't involve anything that's really conceptually hard for us philosophically. Now, we have to change our concept of time, but if you can do that, then actually special relativity and general relativity are not that problematic. Quantum mechanics, on the other hand, people still argue about. I was just at a meeting a couple of weeks ago where we were 5 Christian scientists debating about the meaning of quantum mechanics and didn't agree between ourselves, because quantum mechanics is still not considered to be a fully understood theory. So we can do a lot of things with it, calculate things extremely accurately, and yet still debate about what it all means and what's really going on with it. So part of the reason why putting gravity and quantum mechanics together is hard is because we still don't entirely understand quantum mechanics in some ways as to what's really going on at the basic level.